Let's talk about the Cartesian coordinate system. Okay, this is section 2.R.5. Okay, so when you hear the word Cartesian coordinate system, the words Cartesian coordinate system, that is just a fancy way of describing the XY plane. Okay, the XY plane. And by plane. And by the XY plane, I'm talking about the very familiar x-axis and y-axis. Okay, put together. So that's the xy plane. That's the Cartesian plane. All right, and so let's see, what do we remember from this thing? Okay, well, let's just go to an example. So first of all, example 1. Let's plot the following points on the xy plane. So A, we're going to say is -3, -3. We'll say that B is 5, -7. I wrote a 6. I don't know why. 7. And C is 0, 3. All right, so those are our 3 points, and we want to plot them. So let me draw a probably rough-looking plane here, but that's the best I can do. X-axis, y-axis. Okay, and so let's start off with A. Now remember, the first value is the x value. Okay, this is every point has an x value and a y value. The x value tells you left or right. So it's a -3, so I know that it's left, 1, 2, 3. And the y value tells you up or down. And since that one's a -3, I know that's down, 1, 2, 3. So on this plane, left 3, down 3 would be located right about right here. So there's my point A. All right, so then point B. Well, it is 5 for x, which means to the right 5. 1, 2, 3, 4, 5. And it is -7 for y. That means down 7. So 1, 2, 3, 4, 5, 6, 7. So to the right 5, down 7, about right there. There's my point B. Okay. And then point C, 0 for x, which means left and right, not going anywhere. I'm staying put. So 0 for x. Y is 3, which is a +3, so I'm going to go up 3 spaces. So not going left or right, staying in the middle, and then going up 3. I'm right here on this y-axis. So there's my point C. Okay, and then we could actually reverse these questions, right? I could ask you, if you had a point sitting, let's say right here, let's say that's point D, I could ask you, what is the coordinate values for point D? Well, that's not too hard to figure out, right? I would look at it. How far to the right or left is it? It's to the right 2 spaces, right? And so since it's right 2 spaces, that's a +2. And then it is up 1 space. Up 1 is a +1. So that would be the coordinate point for point D. Okay, let's go on to another type of question. Okay, so points in a plane. We can do a lot with that, actually. So let's kind of talk about describing these points. So let's go on to another example. Okay, this is our second example. Example 2, if we want to number it. Okay, so first of all, I'm going to give an equation. This equation says x plus 2y equals -2. So think about what that means. You have some combination of x values and y values, and whenever you multiply the y values by 2 and then add them to the x values, you always get a -2. Okay, so we're defining a relationship between these values, okay, these x and y values. And so, okay, let's see what kind of sense we can make out of this. Let's say we have the point -3, 2. Okay, we have this point -3, 2. Does this point represent a solution or a valid point for this equation? Does it obey that rule? Well, let's try it out. Okay, I'm going to go and label this with some different colors here. So x and y will be in red. Okay, so I'm going to use this equation, x plus 2y equals -2, and test out this point. Let me fill in everything that's not a variable. Okay, and then x we said is -3 and y is 2. So I'm just plugging these in and I want to see what happens. Okay, so -3 is -3. I'm kind of doing order of operations here, right? 2 times 2 would be the thing I do next. 2 times 2 is 4. That's a +4. And that equals -2, supposedly, right? We're trying to see if this actually works. But I think this is not going to work. Looks like a problem here. Because what's -3 plus 4? That's 1, right? So 1 equals -2. Okay, you end up with some kind of a weird, very false statement, right? This is false, which means that this point never actually works. So we would say that no, this point does not represent a solution to the given equation. Again, answering this question, no, -3, 2 is not a, excuse me, a solution to the given equation, x plus 2y equals -2. Excuse me. So, hold on a second. Okay, let's see if water helps. Yeah, that works. Okay, so now we have -4, 1. Let's try that one instead. Okay, so again, same question. I'm just asking, does this point work for this equation? The x plus 2y equals -2. Let's use blue this time. So x and y will be in blue. All right, so same equation. So x plus 2y equals -2, and we've decided that x is -4 and y is 1. Okay, so -4 plus 2 times 1 is 2 equals -2. -4 plus 2 is -2. So look at this. This actually worked out, right? This is true. -2 does equal -2. So that means that that point works with that equation. That point, that x and that y, they obey the rule that is set forth by that x plus 2y equals -2. Okay, so in this case, we'd say, yes, the point is a solution. Okay, great. Wonderful. Let's move on. Next example, okay, kind of building on what we've been doing. Let's say we have in another equation, y equals 2x plus 1. And this time, we want to find the missing values for x and y. All right, so what am I saying? Let's suppose that we have a point or 2 points that obey this rule. Okay, they obey the rule. The first point is 1 comma something, we don't know. And the second point is something comma 1. All right, so this is 2 problems. We'll treat them as 2 separate problems. Let me actually go ahead and break this up into 2. All right, so the first one, we're saying x is 1. We don't know what y is, but we sure want that point to work with this equation. Okay, so x is 1. We don't know y. We can use algebra and our understanding of this equation here to figure that out. So y equals 2x plus 1. Well, we just said, well, what happens if x is 1? If x is 1, what happens? Okay, we'll plug it in for x and just see what you get. It will tell you what to do. 2 times 1 is 2. 2 plus 1 is 3. Oh, wow, okay. So if we want this point to work for this equation, and x is 1, then y has to be 3. So I'm going to go over here and erase that and say y has to be 3. Let me test that out over here real quick. So y equals 2x plus 1. 3, just do it all in green. 3 equals 2x is 1 plus 1. Does that work? Well, 2 times 1 is 2. 2 plus 1 is 3. Oh, look at that. It works, right? So there we go. We found the point that works with that equation where x is 1. Let's do the same thing for the y value. Okay, so this time we're going to say y is 1. We don't know x. Okay, don't know x. Y is 1. Okay, so back to that equation. Y equals 2x plus 1. Y is 1 equals 2, don't know x, plus 1. Okay, I'm going to leave it as an x because I don't know what it is, so I can't change it out. Now again, using algebra, I can solve that equation. All right, I can subtract 1 from both sides. I'm left with 0 is equal to 2x. If I divide both sides by 2, I'm left with x equals 0. So if y has to be 1, then it turns out that x has to be 0. Again, we can try that out. Sure, why not? Let's do that. Off to the side here, I have y is 1 equals 2x is 0 plus 1. 2 times 0 is 0, so it kind of just cancels that out of the problem altogether. 1 equals 1. Check. All right, so there we go. We can find the missing points, or the missing values, right, x or y, depending on what values we want for x or y. Okay. Let's do one more example. 4x plus 2y equals 2. Okay, and this time I have 2 points, at least 2 half points, right? I have -4 comma something. In other words, x is -4. I want to find y. And I have something comma -1. In other words, y is -1 this time, and I'm trying to find x. Okay, well, what should I do with that? Well, let's plug them in. Okay, so for the first one, I'm going to plug in -4 for x. 4 times -4 is -16. Adding 16 to both sides, it cancels out the -16 on the left. 2 plus 16 is 18. Divide both sides by 2. Y has to be 9. So -4 comma 9. Let's try the one on the right. Okay, so y this time has to be -1. So then what does x have to be? 2 times -1 is -2, so I'll write that as a -2. Adding 2 to both sides to get rid of that -2. 2 plus 2 is 4. Divide both sides by 4. 4 divided by 4 is 1. So if y is -1, then x has to be 1. All right, so the last thing I want to do is plot those points. So let me do that. -4, 9, and 1, -1. Let me write that down. -4, 9, and 1, -1. Okay, so to plot these points, I'll try my best here. We have -4, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. So about right there. 1, -1, about right here. So there's my 2 points. The last thing I want to say is that if I go ahead and draw a line through those points, any point that lies along this line, any point, will actually work for the given equation. Okay, so any of those points would work. We just so happen to find the 2 in black. Okay, so that wraps up this section, section 2.R.5. That is the Cartesian coordinate system, fancy name for the XY plane.